Alright, so let's review some quadratic modeling. Alright, so first of all, let's take a look at this question right here. So an object is thrown upward from a 1,380 feet tall building. The height of the object in feet t seconds after it is thrown can be modeled by the equation. So they give us this equation right here, right, that represents the height of the object after t seconds. So, and then we need to answer these questions here. Okay, so typically when you're doing these questions, right, the first thing you want to do is you want to graph the equation that they give you. Okay, so using our TI Inspire, right, and we need to graph. So you want to go over, click graph, and then you want to type in this equation. So we have negative 16 x exponent 2, and then we have plus 100 x, and then plus 1380. All right, so you just type in this equation right here, and then it'll graph it. All right, and that should be a negative 16. Right, so negative 16x squared. So when you're typing this equation, if the problem is not using x's, make sure that you're using x's, all right, when you're typing it in the TI Inspire. Okay, and then we graph this. All right. Now it's very important that you learn how to use the different zoom features of your TI Inspire. Okay. So I need to zoom out a little bit so I can see the whole graph. So now I would recommend learning how to use the zoom box, zoom out, zoom fit. Right. Zoom standard is like the default. So if you ever want to go back to the default settings, you just go to zoom standard. Okay. So let me try a zoom fit. So if I go zoom fit, what does it look like? Okay, so it looks pretty good, but I kind of need to see a little bit more. So then I'm going to zoom out. All right, so zoom out. Okay, at least now I can see the vertex. I can see the x-intercept. Right. So once you have this, maybe you want to zoom in a little bit. You can go to a zoom box. So basically what we care about is basically the vertex and the x-intercept. So I could do a zoom box. So now I have a good idea and I can see where everything is. Okay, so remember, we can always pick up these labels, all right, move them so that they're out of the way. Okay, so real quick, I'm going to just screen capture this real quick and then talk about when we graph this, right? You have to understand what everything means in the context of the problem when you graph this. Okay, so let me screen capture this real quick. Alrighty. Okay, let me put this right here. Okay. So when we graph this, so you have to think about this problem, what's going on, right? First, make sure you understand what's going on in the problem, right? So what do the x-axis and the y-axis represent? So the x-axis in this situation is going to represent time, right? So the x-axis represents time, right? And the y-axis in this situation represents the height. So the y-axis represents the height, right? The height. Retype this real quick. Y-axis represents the height. So what's going on? So when the time is 0, right? So when the time is 0, so the object has not been thrown yet, right? This is where the object is when the time is 0. So what happens is, so they throw the object, all right? So time passes by, the object goes up a little bit, and then it starts to go down, and then at this point here is when it hits the ground, right? So let's start answering the questions. Part A says, how high is the object 2 seconds after it is thrown? Okay, so once you've already graphed this, right? So basically what you're trying to find is, in part A, you're trying to find, well, what's the height after 2 seconds? All right, so this is the notation that we use to represent that. So the height after 2 seconds is going to be equal to. Now, you have a choice. You can take 2, plug it in here and here for t, and just work it all out if you want, right? Or what you could do is you could just go to the TI Inspire. Since we've already graphed this, we can just go to Control T. it brings up to 10 the table menu, right? So basically, it tells you based on this equation, if x is this, this is the y, right? So we want to know, well, if x is 2, what's the y? What's the height? So the height is 1,516, right? So this is a real fast way with the calculator to find the answer instead of plugging in the 2 here and here and working it all out, which takes more time. Okay, so the height after 2 seconds is 1,516. So 1,516 feet. Right, so that's the answer to part A right there. Part B, how long does it take for the object to hit the ground? So you have to understand in this diagram, it hits the ground right here, right? So basically this is when the height, remember the y-axis is the height. At this point here, the height is 0. So if the height is 0, this is where it hits the ground. So this is the x-intercept, right? So on your TI Inspire, if you want to find the x-intercept, now if you want to get out of this table menu, you just go to Control T again. It'll take you out of the table menu. So we want to find this x-intercept right here. So just go to Menu, Analyze Graph, 0. All right, and just highlight over the x-intercept, and then we'll get the values for the x-intercept. Okay, so the question, how long does it take? All right, so how long does it take? Right, remember that sounds like time. Remember our x-axis is time, so that means your answer is the x value of this coordinate right here. Okay, so the x value is 12.9. Okay, so it looks like it's going to take 12.9 seconds. Okay. Part C, let's see what part C is asking for. What is the highest point that the object reaches? So the highest point, that's the vertex of the graph. So if you want to find the vertex, you just go to Menu. So the highest point is the maximum. Then highlight over the highest point, and then we'll get that value right there. So now you need to know if it's asking what is the highest point, is that the x value or the y value? So if it's asking what is the highest point, that means what's the height? What's the highest height that the object gets to? So you have to understand that's the y value, right, of the vertex, right? Because the y-axis, remember, is the height. So the height, right here we have is 1,536. Okay, 1,536. You could round to 1 decimal if you want, so it looks like 0.3, right? And then that's in feet. Okay. All right. Now, part D. How long does it take for? How long does it take to reach its highest point? Right. So how long does it take to get to the highest point? So in part D here, you have to understand that when it's asking for how long does it take, that represents time, right? It's asking for how much time does it take. So time is the x-axis. So if you go to the vertex, right? So the highest point is the y value. So that's 1,536, right? But how long does it take to get there? That's the x value. So it takes 3.125 seconds, right? So if we just round to 1 decimal, about 3.1 seconds. So about 3.1 seconds, right, to get to the highest point. Okay, that's part D. Let's take a look at part E. How long does it take for the object to be 1,000 feet high? So we want to know, when is the object 1,000 feet high? Okay, so we want to go to tab, right? Because we're going to graph 1,000 feet. So press tab. So for function 2, we're going to type in 1,000. So press enter, right? So here's this red line here represents 1,000 feet. So we want to know, when will it be 1,000 feet high? So when will it be is the time. That means the x-axis. So let's find the intersection here. So we go to intersection right here. So we get this point. So if the question is asking how long does it take for the object to be 1,000 feet high, right? That's the time. Time is the x-axis. So it takes 8.9 seconds. So part E, the answer is 8.9 seconds. Okay. All right, so let's take a look at this next example here. So it says a cheesecake company's cost can be modeled by the equation, right? So they give us the equation that represents the cost here, okay? Where capital C represents the cost in dollars per day, and X represents the number of white chocolate raspberry cheesecakes made per day, okay? So the first thing you want to do is you always want to make sure you read the question and understand, right, what the question is about, okay? So what is this question dealing with? All right, so it's dealing with cost and how many cheesecakes are made per day. The next thing you want to do is you want to make sure you understand, okay, well, the x-axis, what represents the x-axis and what represents the y-axis, right? So first of all, let's graph this real quick. So let me graph this. So 0.25. So on your TI Inspire, so we have 0.25 x squared. And then we have minus 15x. And then plus 420. All right, so now, so you don't see anything, right? Because remember I told you maybe you have to learn to play with the zoom. So typically you can always try a zoom fit to see what it looks like. So zoom fit, okay, I see part of the parabola now. So it looks like I need to zoom out a little bit. So let's zoom out a few times so that we get an idea what the parabola looks like. Okay, so we've got an idea of what the parabola looks like here. And then typically I'll do a maybe zoom box afterwards and just kind of highlight the part of the graph that I really want to see, right? Which is this right here, okay? And then let's kind of move this label out of the way, okay? So we've got this graph right here. All right, let me screen cap this real quick. All right, so this graph right here, let me just put it right here for now and I kind of just talk about it. So let's just make sure we understand what this graph represents, okay? So right now, what does the x-axis represent? Now remember, this problem is dealing with two things, cost and the number of cheesecakes made, right? So in this situation, the x-axis is going to represent, right, the number of cheesecakes made, right? So the x-axis represents basically the cheesecakes made. All right, so it's important for us to understand that, right? And the y-axis in this case represents the cost, right? The cost of the company. So basically what happens is, if you think about it, all right, if no cheesecakes are made, this is what the, whatever this value is, this is the cost for the company. Now, as more cheesecakes are made, so the costs slowly start to decrease a little bit. So you might want to think like, well, if they're making more cheesecakes, shouldn't the cost go up? Well, no, because if they're making cheesecake, they can sell them. So when they sell them, they make profit. So when they make profit, all right, they're lowering their costs because they're making profit, right? So let's make sure we understand the situation, what's happening, and then now let's go answer the question. So let's go to the questions now. All right, let me erase this, or at least minimize this real quick. Make this a little bit smaller. Or I'll just actually delete this for now. So, all right. So let's start answering the questions. A, what is the cost if 0 cheesecakes are baked, right? So if 0 cheesecakes are baked, right? So remember, you have two options of finding this. You could plug in 0 for the x and then just work it out, right? Which is going to be obvious. It looks like it's going to be 420. So basically the cost when 0 cheesecakes, right, are baked would be 420. Now a fast way to get this answer is to go to Control T. All right, here's another option. Just scroll up to 0. When x is 0, what's my y? It's 420. Okay, so the table menu on the Inspire is very useful, right? And you should know how to use it. Okay, Control T to get out. So that's A. B says, if 0 cheesecakes are baked a day, why does the company still have some costs? So we kind of have to think a little bit, right? So if they don't make any cheesecakes, how come they have some cost? Because the cost of the cheesecakes is not the only cost, right? That the company has. So the company has other costs, right? So why does the company still have some costs? Basically, the company has other costs, right? Like maybe rent, right? Utilities, right? Salaries, right? They have to pay their employees. So since the company has other costs, right? It doesn't matter if they make 0 cheesecakes. They're still going to have some sort of cost because they have other things that they have to pay for. Okay? Part C. Find the cost if 12 cheesecakes are baked. Okay? So we want to find the cost if 12 cheesecakes are baked. So remember, you have the option. You could just plug in 12 where the x is and then just calculate this. Or since you've already graphed this, we can just go to Control T, bring up the table, just scroll down, go to 12, right? So if we go to 12, we get 276. So the cost, if 12 cheesecakes are baked, would be 276. Okay? Part D says, using your answers from parts A and B, right? Explain why the cost is decreasing as more cheesecakes are being baked. Okay? So if we take a look at our answer from A, so if we make 0 cheesecakes, the cost is $4.20, right? If we start baking more cheesecakes, right? So if we make 12 cheesecakes, the cost is now $2.76. So why did it go down? That seems kind of weird, right? Because if you're baking cheesecake, shouldn't your costs go up because you're spending money to make the cheesecakes? So what's the reason why the cost is going down? Okay, so that's basically the tricky part with this question. So using your answers from part A and B, which is 420 and 276, explain why the cost is decreasing. Well, the cost is decreasing because, well, if we make cheesecakes, we can sell them, and when we sell them, we're making a profit. So when you make a profit, you're decreasing your cost. Okay, so that's why the cost is decreasing. Okay, so basically you just want to explain that, all right, briefly, that, so explain why the cost is decreasing. The cost is decreasing because, all right, when you make some cheesecakes, right? Some cheesecakes, you can sell them for profit. You can sell them for profits, thus, all right, lowering your cost. That's why the cost is going down. Okay. Part E. How many cakes should be baked per day to minimize the cost? So if you want to get the lowest cost possible, right? So going back to the graph, let's get out of the table here. We go to Control T. So we want to find the minimum value here for the cost. So we go to Analyze Graph, Minimum, highlight over the lowest part. So we get our value here. So it looks like, so what does this mean here when X is 30 and the Y is 195? So you have to understand that, remember, the X-axis represents cheesecakes made. So this means that if we make 30 cheesecakes, all right, this will minimize our cost. And our minimum cost will be $195. Okay? So how many cheesecakes should be baked per day? So you have to understand part E here, where our answer is the X value of the vertex. So basically this was 30 cheesecakes, 30 cakes, all right. What is the minimum cost? That's the Y value of the vertex. So the minimum cost was $195. Okay. G, find the cost if 40 cheesecakes are baked. All right. Find the cost if 40 cheesecakes are baked. All right. So once again, if you want to find the cost, you could take 40 and plug it into the equation for x, right? And then work it out. Or you could just use the table. It's really up to you. So I would just go to Control T and just scroll down to 40, right? So just keep on scrolling down. Oh, we get 40 right here. We get 220, okay? So if 40 cheesecakes are baked, right? So the cost, if 40 cheesecakes are baked, so we've got the cost. So the cost if 40 cheesecakes are baked is equal to, and that was what? 220. Okay. All right. So part H here says, explain why the answer in part G is greater than the answer in part F in the context of the problem. Okay. So you notice our answer here. So the answer in part G, which is 220, so this is higher than our answer in part F, which is 195. Now remember our answer in part F, this was the minimum cost, right? So this is the best that we can get, right? In terms of lowering our cost, okay? So how come the cost started going up, right? Now remember in part F, the minimum cost happens when we make 30 cheesecakes, right? When we make 30 cheesecakes. Now in part G, if we make 40 cheesecakes, the costs start going up, right? So you want to kind of think, well, why does this happen? Okay? So if you think about it, if a company makes too many cheesecakes, what's going to happen? They're not going to be able to sell them all, so they've spent money to make the cheesecakes, right? So their cost is going up, but they were not able to sell them, right? So they couldn't make profits. So that's why their cost went up, right? And it doesn't continue to decrease, okay? So basically, you kind of just want to explain that. So we have explain why the answer in part G. So so the minimum, so the minimum cost occurs when 30 cakes are made, right? So when 30 cakes are made. All right. If more than 30 are made, the cost begins to go up because too many cakes are made and cannot all be sold, right? So because too many cakes, all right, too many cakes. Let me kind of rewrite that a little bit better. Too many cakes are made and can't all be sold, right? So they're kind of wasting money making the cakes, and then they're not able to sell them because they've made too many that day. Okay.